Now we're going to start our modeling. The LM function here we've seen before with linear regression. Now we're going to do something called multiple linear regression. But we're going to start off with the simplest model. The simple idea is that the home team is a big determinant of attendance. In other words, big market teams, very popular teams are going to have higher attendance. So the fact that it's the Yankees or the Dodgers is going to impact attendance more than, say, a small market team. And that's what this model is saying. We're saying that the home team will predict the attendance. It's another rule of thumb. When you see the tilde in the model statement in the middle there between attendance and home, the way to read this is attendance is modeled as home. So the tilde can be read, quote, is modeled as. So attendance in major league ballparks is modeled as the home team. And we'll run through those 24,000 games, we'll run that model to see how well it does, to see how well the home team predicts attendance. That's what the LM function does. It does a modeling, a linear modeling of the attendance is determined by the home team question. We're going to use the retrosheet data frame, and we're going to assign that to something called attendance model. So let's run that command and see what happens. Hit run. It worked. The summary command will give us a summary of the results from the LM function, results of our model. So let's run the summary command and look at the results here. Now there's a lot of information here. So let's start at the top. Here's the summary command. It gives us a review of the model we were looking at, that attendance is modeled as home team. Residuals is, you'll learn more about this in your statistics class, but generally we know what min and max are, and we know what the median is, first quartile, third quartile. We generally want these numbers to be mirrors of each other. In other words, that represents something like a normal distribution. We want the median to be near zero-ish. We want the first and third to be negative and positive around the same number, and min and max to be about the same number, so there's no great outliers. These residuals look fairly normal, just based on these 5 numbers, so that's a good start. Then we come to this list of home, Arizona, Atlanta, Baltimore, Boston, and all this information here that comes from the modeling command, the LM command. As we go through this, let's start with a reminder. There are 2 major categories of variables in statistical languages like R. There are continuous variables like numbers. They're numerical, they have decimal points, they span a certain range, and they're continuous throughout whatever range it is. And then there's categorical variables. In R, those categorical variables are called factors. So you'll see factors in R documentation. Now, factors are variables in R which take on a limited number of different values. So when we look at the variable home, when we look at home up here, when we look at home, home is a categorical variable. It's got a limited number of values. It's got 31 different values, in fact, representing the 30 different teams. In this case, it's 31 different variables because we have both Montreal here and Washington in our data set. Remember the Montreal Expos in the middle of the decade, we're looking at move to Washington, D.C. So we have 31 different values in our variable home. If you want to learn more about factors, consult documentation, go to Google, but there's good functions in R, levels function and the factor function, that help you manipulate factors within the R language. That's just a reminder about categorical variables or factors versus continuous variables. And they really matter in modeling. And you sometimes have to make sure you're getting this correct in modeling. Now, when I do this model, attendance is modeled by the home team. Home is a factor. It's a categorical variable. It's got different values. And what we get here in the result of the LM function, the result of the LM function call, where we pass it our model, if the model includes a categorical variable, we're going to get this setup here. This is the standard return in an R call of a categorical variable. So what are we looking at here? There are listed 30 different home rows here in the output. And there's one row called the intercept. This intercept actually is represented by Anaheim. And you might have noticed Anaheim is not in this list. Alphabetically, Anaheim would be first. So what R does is take Anaheim as something called the reference level or reference category. Some people call it the reference cell. It's the reference within the list of values in the variable called home. So Anaheim is our reference. Now, Anaheim was just chosen because it was the first alphabetically in our factors. But many times when you're modeling data and you have a categorical variable, a lot of times you have a control in an experiment, for example. You have controls and interventions when you do an experimental study. In that case, you want to be very careful about which value in your categorical variable is named as the reference level, because you want the control to be the reference. That's why it's called a reference. In our case, it doesn't matter much what we chose as a reference. Anaheim was chosen. In other modeling efforts you may do, choosing the reference actually might matter. So Anaheim is the reference in this model, and all the other values for the home variable are called dummies. The dummies depend on the reference. And here's where this matters. You can see we've highlighted the number 36,451. This, in fact, is the average attendance at Angels home games for that whole decade that we're studying, the whole decade of our data set. So 36,451 is the average over that whole decade for Anaheim. And we call that the reference. That's why it's called the intercept, and it's the reference. Every other number here is relative to the 36,451. So Arizona on average for that decade is 5206.4 less than the Anaheim value. Cincinnati is over 10,000 people less. Florida is 19.7 thousand less than the Anaheim reference. So we have a reference estimate for Anaheim, and all these other numbers here listed under the estimate column are relative to Anaheim. Now, if you scan this column, you see a lot of negative numbers. Remember, Anaheim was just chosen as our reference. It turns out, when you look at the whole data set, the average of the whole data set for that whole decade of all major league games is 30,319. So most of these numbers here, as you look at these numbers, most of these numbers are going to be negative dummy numbers relative to our reference here. The reference is actually greater than our mean of the whole data set. So that's why you see a lot of negative numbers in this list. As you're going up and down this list, you see lots of negative numbers.